Hello, in this video I'm going to solve question 1 from the problem set number 1. Let us read the question together first. Show that the function capital F, defined on the closed interval from -1 to 1 by capital F of x equals to 1/2 times ln of 2 plus x over 2 minus x, is an antiderivative of the function little f, defined on the same closed interval from -1 to 1, but by this rule, little f of x equals to 2 over 4 minus x squared. Okay, in order to show that, I need to show that the derivative of the capital F calculated at every point in this closed interval matches with the value of the function f of x calculated at the corresponding chosen value for x. In other words, I want to show that the derivative of f at x, where x belongs to that interval, exists and is equal to f of x. Okay? Of course, I can start differentiation directly, but it would be much simpler if I use this formula from the natural logarithm. So we know that if a and b are positive real numbers, then ln of a over b is equal to ln of the numerator minus ln of the denominator. And here I can safely use this formula because here 2 plus x is going to play the role of a, and 2 minus x is going to play the role of b, and x belongs to -1 and 1, so x is somewhere between -1 and 1. So for all choices of x in this interval, both the numerator, 2 plus x, and the denominator, 2 minus x, are positive. So I can use this formula. Okay, so what I do first, I rewrite capital F of x in this form. So I just write 1 over 2, and then I have ln of the numerator, which is 2 plus x. Now let me put a pair of brackets around this, and then minus ln of 2 minus x. And now I start differentiation. To differentiate, I'm going to use this formula that you already know. If u is a function of x, and is positive in the domain that I am working, this ln of u is differentiable, and its derivative follows this rule. It is u prime in the numerator divided by u in the denominator. So I will use this rule here and there. In this case, u is 2 plus x, and in this case, u is 2 minus x. So what I will do, I will calculate f prime of x. So capital F prime of x equals to 1 over 2 is a multiplicative constant. So then for the first one, 2 plus x goes to the denominator, and its derivative, which is 1, goes into the numerator. And then I have minus for the second one, 2 minus x goes to the denominator, and its derivative, which is -1, goes into the numerator. And now I want to simplify that. So what I do, I take the common denominator. The common denominator is the product of 2 plus x and 2 minus x. Okay, for the first one, I write 2 minus x. But if you look here, there is a minus sign here, there is a minus sign here, so it becomes positive. And then I will have 2 plus x here. Okay, so I divided this by that. It becomes 2 minus x. I multiplied that here. I divided this by this. It becomes 2 plus x. I multiplied it here. But of course, these two minus signs cancel out and I have positive. Okay, now it is clear that this x and x are gone, and then what is left for me in the numerator is 2 plus 2, which is 4, but I have a 1/2 here, which gives me 2 in the numerator, yes? So this means that this becomes equal to 2 over, and in the denominator, by the way, I have the conjugate rule, so when I multiply them, it becomes the first one squared minus the second one squared. And if you compare this with little f of x, you see that's exactly f of x. So I was able to show that the capital F is differentiable everywhere from -1 to 1, and its derivative calculated at an arbitrary point x matches with the value of the little f of x. So this means that capital F is an antiderivative of little f of x on this interval. Of course, I can extend this interval to up to -2 and 2 open interval. Yes, I cannot go beyond that, because if I go beyond that, this function is not differentiable anymore. And I cannot, of course, include -2 and 2, because, for example, this function is not differentiable at 2, or it's not differentiable at -2. So still I can extend the domain, but I have to keep it somewhere as a subset within the open interval -2 and 2. Okay,